Hello and welcome back to another video documenting June 1st severe weather research design process of the aerial supercell measurement system. It's been a while since our last video. The last video actually documented kind of what we were doing in terms of design characteristics and outlining all that. Now we're getting into the more prototyping side of things. To start off, we're going to be using sensor breakout boards in conjunction with Arduino microcontrollers to achieve what we are looking for in terms of measuring parameters. I'm going to go over some of the sensors and stuff that we have here, and we're going to start soldering them up so we can start prototyping them out on a breadboard. These are the electronic components that we have thus far. These four items up here are long-range radio transceivers, meaning that they can be configured to either receive radio signals or send out radio signals. These have an open air range of anywhere between 5 to 20 kilometers depending on how you configure them. So these are going to be great modules for long-range data acquisition. Over here is an Arduino Mega. The Arduino Mega is a huge microcontroller. Well, I say huge just compared to other types of Arduinos like these guys down here. These are Arduino Nanos. This has a lot more processing power than what these guys have. So the main core of the sensor package is going to be based around this, as there are a lot of sensor libraries that we have to use in order to crunch the numbers internally and get them ready for data transmission rather than just serial outputs. Serial outputs are no good to us, so we have to have them interpreted by the microcontroller so we have readable data. Down here we have the micro SD card reader writer, so we can do that onboard storage. This right here is an inertial measurement unit, also known as an IMU. These are commonly found in drones, and they determine accelerations and orientation. And basically it's an onboard gyroscope with accelerometers. And then in here is a GPS module, so we can track latitude, longitude, and altitude. Of all of the components that we have right now, only a few of them actually pertain to the sensor package. First off being the Arduino Mega, which fortunately already has all of its header connections soldered in, so we don't need to have to worry about that. We have to use the GPS module because that gives us all of our locational parameters, the IMU sensor, the micro SD card reader, and one of these LoRa transceivers. The one thing that we do not have right at this moment is the atmospheric sensor, but that should be coming in the coming days. So now what we're going to do is start to solder the header pins on a lot of these other sensor boards that need to be configured as we desire. So we're probably just going to put all of the header pins into all of the holes, but granted, there isn't a need for all of these pins and connections. For example, this GPS module here has 9 connection places, but I think we only need to use 4 of them for it to do what we need it to do. So let's start soldering some of these devices. Alright, so now that we have one of our modules put together here, we have the GPS module here. I have a small breadboard that we're going to test this out on. We first got to make sure that our Arduino Mega here works properly, and to do that we upload a blank sketch to it, and the little onboard LED should blink according to the sketch. I have the blank sketch here, and what we do is we plug this into our computer here, then we can upload. Yeah, so this LED is blinking, meaning that the sketch is working successfully. So I think this Arduino already had the blink sketch. It is common practice to upload a blink sketch to make sure it works, so they probably did it before they shipped it out. But so we know that works. So now what we can do is upload a sketch that is intended for our GPS module here. In order to get our GPS to work, we need to do some wiring here, just using some of these jump leads in order to complete connections where they need to. For our purposes, we only need to make 4 connections to get the GPS to do what we want it to do. We need to connect it to this VIN pin, this ground pin, the RX pin, and the TX pin. So the VIN pin is where we get the power, ground is our ground, and then the RX and TX are the transmitting and receiving serial wires that transport the serial data between the GPS module and the Arduino. So the Arduino is eventually going to take those serial commands that come from this and interpret it as the GPS coordinates based off of the libraries that are uploaded. So first off, we need to connect our power pin, which is the VIN, which is this one right here. So that is our VIN pin. And if we look on our Arduino, we'll see this 5-volt pin over here. So this is a 5-volt module, so we will connect that over there. Perfect. Next, what we will do is connect our ground. So there are a few grounds on this breakout board here, but we'll put it next to our 5-volt pin. Then our RX and TX pins. So our RX pin is actually going to be our 0 pin here. In the sketch I configured it so that it matches what's on here on the Arduino. So if we connect our RX pin right here, put that to our 0 pin. And lastly, the TX pin to pin number 1, which is also labeled on here as the TX. And just like that, we should be wired up and good to go, and then we can now upload the sketch to this Arduino to start running our GPS module. Alright, so now we are ready to run our test sketch in order to make sure that our GPS module is working in conjunction with our Arduino. So here's the sketch. It's a pretty simple, just take the serial outputs and convert them into GPS coordinates, latitude and longitude. So now let's plug this in so we can upload the sketch to the Arduino. So now that that's in, what we will do, we should have a connection. So we're going to upload said sketch to our Arduino. Now that it is done uploading, we can open our serial port. For some reason I can't get the serial monitor to pop up on my computer to show you the data coming in, but right now there wouldn't be any data coming in because this GPS module is inside right now. So this blinking fix button here means that there is no lock with any GPS satellites, so it would probably just return a bunch of zeros right now. But the good thing is that the TX LED indicator on the Arduino Mega here is blinking every second, which means that it is transmitting data to the serial monitor. Even though we can't see what that data is, with it being likely zeros, that LED is giving me the indication that it is working as intended, which is good. Alright, so it's a little bit later in the day, but what just arrived in the mail is our atmospheric sensor. Now this is what is going to give us our temperature, humidity, and barometric pressure. So let's get this soldered up and test it out on our Arduino. There are 4 connections that we need to make with our atmospheric sensor breakout board in order for it to perform as we intend. The first is our power pin, our ground pin, and then also our communication pins. In this case, we're using the I2C communication protocol, which is going to use these SDA and SLC pins on the Arduino Mega. Now let's hook it up so we can run a test sketch to make sure that our breakout board works as intended. So we're going to hook up the ground here. pin. This breakout board is 5-volt ready, just like the last one, which is nice, so we don't have to worry about stepping down any of our communication connections to 3.3 volts, which most of these sensors usually do. They take 3.3 volts, but in this case this was made 5-volt ready, which is good for our purposes. It just makes hooking these up a lot easier. Just like that, we're ready to upload our test sketch to make sure that this is performing as intended. Alright, so on my screen here we have the Arduino IDE open with a test sketch that should display the basic parameters that our BME 280 atmospheric sensor should give us. So we're going to plug this into the computer. And then it should already be configured to take the upload. Now uploading. And now we should be good to go. If we open up the serial monitor, hopefully it opens this time. So I figured out what was wrong with the serial monitor. And if we look real quick, here at our Arduino, if I can focus here. Maybe I should just switch to autofocus. Anyway, so we see this blinking LED, which means that it's transmitting to our serial monitor on our computer here. And if we look, we are getting a string of values that translate to, if I can get the focus right here, there we go. That translate to actual values of the atmosphere of this room. So, in short, it seems like we have a good working sensor and that none of the solder connections were messed up. I botched some of the solder connections. They're not the greatest, that's for sure, but it works and we're getting good data back. And I will have to go outside and get a GPS fix later on and try the GPS to see if that also works, which I assume it does, but right now we're getting good data back, which is always a good sign.